Good day everyone and welcome to another video lesson. In this session, we will learn how to do the product form algorithm or solution in finding the binomial coefficient as used in the binomial theorem. Here are the learning objectives. Please pause the video and read them closely. Here we present the product form of the binomial coefficient. Notice that in this form there are no factorials. Instead, we work directly with the individual factors in both the numerator and the denominator. So note, for the numerator, there are R number of factors. So factors begin with n, and then we have n minus 1, and then we have n minus 2. So we have n times n minus 1 times n minus 2, so on and so forth, up to the last factor, n minus r plus 1. So again, the last factor is n minus r plus 1. So for example, if r is equal to 3, so the factors will be n times n minus 1 times n minus 2. So the last factor is n minus 2. Why? Because n minus 3 plus 1 is equal to n minus 2. Now for the denominator, we simply expand r factorial. So we have r times r minus 1 times r minus 2, and so on and so forth times 1. So again, this is the product form. And the advantage of this product form, there is no need for cancellation between large factorial terms. Let us now derive the factorial form of the binomial coefficient from its product form. So start with the product form. Okay, and then step number 2, multiply both the numerator and denominator by n minus r factorial. So see, we have n minus r factorial here in the numerator and n minus r factorial here in the denominator. And then recognize the numerator as n factorial. We can see that the numerator reconstructs the full factorial of n, and then simplify the expression. So now we have the factorial form. Alright, so let's use the product form in binomial expansion. So please take note again and recall the binomial theorem. So for the expansion, a plus b raised to the power n, it is a summation of n choose r, a raised to n minus r, br, where r is from 0 to n. And recall the product form. So for the coefficient extraction, and we have the product form. So this is the combination operation, n choose r, and this is the product form. So n times n minus 1 up to the last factor n minus r plus 1 all over r times r minus 1 up to times 1. So here is our example. Find the coefficient of x cubed y squared in the expansion x plus 1 raised to the power of 5. So first, we identify n and r. So the exponent of the binomial is 5, so n is equal to 5. And the exponent of y is 2, so r is equal to 2. So the coefficient will be 5 choose 2, so r is equal to 2. So we're going to have 2 factors in the numerator starting from 5. So we just have 5 times 4. And for the denominator, we're also going to have 2 factors starting from 2, so we have 2 times 1. 5 times 4 is 20, 2 times 1 is 2, and 20 divided by 2 is 10. Here's another problem. Find the coefficient of x squared in the expansion 2x minus 3 raised to the power of 4. So step number 1, recall the binomial theorem. So you write the formula for retention and recall. We're going to have 2 solutions here because addition is commutative. So a and b can be interchanged. So again, step number 2, identify the given values. So the exponent of the binomial is 4, so n is equal to 4. And we have a is equal to negative 3 and b is 2x. So since we're looking for the coefficient of x squared, we need the term where the power of x is 2. Thus, br is equal to 2xr and must include x squared. So this will happen, x squared will happen only when r is equal to 2. So hence r is equal to 2, and we consider the term b squared is equal to 2x raised to the power of 2. So we have 4x squared. So here is solution number 2, another way of determining r. So there's another approach to determine the value of r directly. So for the given expression, 2x minus 3 raised to the power of 4, alternate assignment, n is equal to 4, and we assign 2x for a and negative 3 for b. Alright, so again, this is the general term. The term of r plus 1 is equal to n choose r is equal times a raised to n minus r br. Alright? Since a is equal to 2x, the power of x in a raised to n minus r is n minus r. So to obtain a term containing x squared, we set n minus r is equal to 2. And then our n is equal to 4. So substitute n with 4. We now have 4 minus r is equal to 2. And do a little algebra. Then we have now r is equal to 2. The next, compute the binomial coefficient 4 choose 2. So using the product form, we have n is equal to 4 and r is equal to 2. Since r is equal to 2, there would be 2 factors in both the numerator and denominator. So starting from 4 in the numerator, so we now have 4 times 3. And starting from 2, for the denominator, so we have 2 times 1. 4 times 3 is 12, 2 times 1 is 2. 12 divided by 2 is equal to 6. So here's our explanation for the product form. In the product form, the numerator starts from n and descends r times, while the denominator starts from r and descends up to 1. So this gives a straightforward way to compute binomial coefficients without using factorials. And now we determine the specific term in the expansion. So recall the general term. The term of r plus 1 is equal to n choose r times a raised to n minus r b raised to the r. So we use this to find the term containing x squared in 2x minus 3 raised to the power r. Now we substitute the known values and computed values. So again, 4 choose 2 is equal to 6, and we have n is equal to 4. We assign 2x for a, negative 3 for b, and r is equal to 2. So third term is equal to 6 times 2x raised to 4 minus 2 times negative 3 squared. 4 minus 2 is 2. So we now have 6 times 2x squared times 9, and that will be equal to 6 times 4 times 9x squared. Then multiply the numerical coefficients. 6 times 4 times 9 is 216, and copy the variable part, x squared. So the third term is 216x squared. Now it's your turn, so please pause the video and try solving the following 3 practice problems on your own. Always remember, learning mathematics becomes more meaningful when you learn by doing. Enjoy your practice and have fun expanding binomials.